Good morning to all. My name is Arvind from Computer Science Engineering. Today's my topic is program to insert, delete and display elements in queue using arrays. Outline: introduction of queue, algorithm to insertion, algorithm to delete, algorithm to display, introduction to data structures and conclusion. Introduction: queue is a linear data structure in which we add elements to one end and remove them from other end. Items enter queue at back and leave from front. The first item to be inserted is the first to be deleted. A queue is therefore called a first in first out FIFO property. Queue operations: enqueue, dequeue, get head. Enqueue: insert an element at the rear of the queue. Dequeue: delete an element at the front of the queue. Get head: get the element at the front without deleting it. Here ticket counter open at both ends. Person who enters first receives the ticket first, and the person who enters last will receive the ticket last. Algorithm to insertion. To insert an element into the queue, check whether queue is full or not. Rear equals to size -1. If it is full, then display queue is full and terminate the function. If it is not full, then increment rear value by 1, rear plus and set queue of rear value. Algorithm to insertion. Algorithm: void insert int value. First start if with empty, rear equals to size -1, then display queue is full. Else, if front equals to -1, then front equals to 0 and rear plus queue of rear equals to value, display insertion success and stop. Algorithm to deletion. To delete an element from the queue, check whether queue is empty or not. If front equals to rear, if it is empty, then display queue is empty and terminate the function. If it is not empty, then increment the front value by 1, front plus, then display queue as deleted element. Algorithm: first start if front equals to -1 or front greater than rear, then display queue is empty, and else display deleted queue front. If front equals to rear, then front equals to rear and rear equals to -1 and front plus, then stop. Algorithm to display. To display the elements of the queue, check whether queue is empty or not. Front equals to rear. If it is empty, then display queue is empty and terminate the function. If it is not empty, then define an integer variable I and set I equals to front plus 1. Display queue of I, value and increment I, value by 1 I plus. Repeat the same until I value reaches to rear, I greater than equals to rear. Algorithm: void display start if rear equals to -1, then display queue is empty. Else, display queue elements are false, or if I equals to front, I greater than equals to rear, I plus, display queue of I and stop. Data structure are essential components that help organize and store data efficiently in computer memory. They provide a way to manage and manipulate data effectively, enabling faster access, insertion and deletion operations, common data structures including arrays, linked lists, stacks, queues, trees, and graphs, each serving specific purpose based on the requirements of the problem. Understanding data structure is fundamental for designing efficient algorithms and optimizing software performance. A queue data structure is a fundamental concept in computer science used for storing and managing data in a specific order. It follows the principle of first in, first out, where the first element added to the queue is the first one to be removed. And conclusion, a linked list is a dynamic data structure which is sequence of nodes. Advanced linked lists are circular and double linked list. It is difficult to locate an item in the middle position. And thank you.